All right. Well, welcome everybody. Thanks so much for joining us this afternoon. If you're in Wyoming or in the States, or this evening, if you're in South Africa. For those of you who don't know me, I'm Samuel Singer. I'm the founder and executive director of Wyoming Stargazing. And I am really excited to be connecting with all of you, as well as with our special guest, Ben Coley, who is down in South Africa right now. Ben is the founder of Celestial Events South Africa, and he's going to tell you a little bit more about where he is and the equipment he's going to be using tonight to help us do some stargazing. And so Ben, thanks so much for being here, and yeah, tell us a little bit more about your setup.
Yeah, thanks very much, and welcome everybody. Thanks very much for joining me here. As you can see, the darkness behind me, unlike Sam's page there, is genuine. It is just gone 11 o'clock at night over here. And yeah, thanks very much for joining us. So I'm actually sitting outside at the moment. I've got my equipment set up next to me. I would show you, but I don't want to move any cables and things at the moment. But next to me is my Meade 10-inch LX200 GPS telescope. It's just on an alt-az fork mount at the moment, and I've got my Nikon camera with a focal reducer because it's quite a powerful telescope in terms of zoom. It's about 2,500 millimeter focal length. So I've got a f6.3 focal reducer on it to look at some of the objects we're going to have a look at this evening. So I'm going to take some pictures, put them on the screen, and hopefully you guys will be able to see them. And then we'll, I'm sure between myself and Sam, we'll show you some sort of more official images as well, Hubble and European Space Station one, so we can have a serious look at it. But the idea is to show you guys some of the things that you simply cannot see from up there. I knew I'd remember what it was I wanted to ask you, Sam. It was how far south you can actually see from where you are in Wyoming. What your most what constellations are closest to the horizon for you?
Great question. So during the middle of summer and early fall, I think we can see the very top of the Centaur constellation and just a tiny bit of Fornax, but that's about it.
Okay, so you just get a little bit. Okay, because Fornax for me is pretty much at the zenith at the moment.
Okay, yeah, so that's just barely at our horizon.
Yeah. Yeah, so just a little bit of background for who I am and what we here do at Celestial Events. So actually my background is in game ranging or field guiding, safari guiding, whatever you want to call it. I'm from England originally. I've been in South Africa for about 15 years. You can probably tell from the accents that it's the English origins are still there. But yeah, I was a safari guide and guide trainer for about 15 years. And we are, not only is it an amazing job to have for obvious reasons, but we're also privy to some of the darkest skies that you're going to come across. I've spent a lot of my time working in the Kruger National Park, where you're looking at Bortle sky indexes of 1 and 2 in most places, maybe 2.5 in the more populated regions of the park. And for guides in general, if any of you guys have been on safari, hopefully you'll remember your safari guide, and hopefully he was knowledgeable and entertained you. But it's something that unfortunately is sadly lacking in a lot of the safari experience, is talking about the stars, because we've got such clear skies. And so actually Celestial Events was founded under the basis that the governing body whom regulates the guiding industry, I approached them and suggested that the industry could use a bit more knowledge in astronomy, because it's always been a passion and a hobby of mine. They agreed to it, so we've now put together a qualification for all field guides that they can sit and try and pass, which will hopefully set them up to give huge amounts of awesome knowledge to guests, as just another, as I like to say, another string in their bow of ways to entertain guests whilst they're on safari. And it's somebody, if I can figure out how to do it, let me just share the screen quickly. That's not what I want. Where's my picture? Okay, so this is me, and you can just see my equipment behind me when it loads. There we go. So there's my Meade LX200 in the background, and this is the manual that we've written for FGASA, which is the Field Guide Association of South Africa. And in terms of its contents, sort of on purpose, we've tried to not go into too much depth from a scientific point of view, because not every guest is going to want to have that level of depth. So where possible, we've tried to concentrate on the cultural areas, the mythologies, and certainly the environmental importance of astronomy in terms of where the elements have come from and how that affects weather cycles and so on and so forth. Yeah, and it's been received very well. I've done quite a lot of training over the last year or two that Celestial Events has been operating. Some of you may have heard of some names like Londolozi, Sabi Sabi, Singita. There's quite well-known lodges out here that we've trained at. So yeah, so very, very excited, and it's going very well. So I thought I'd give you a bit more of an indication as to exactly where I am. I'm not sure if any of you guys have been to South Africa before, but I'm in an area called Nelspruit, which is the capital city of the province, or the state, if you like, of Mpumalanga, which is rather beautifully means place of the rising sun. Again, let me just share the right screen. And hopefully Google Maps, if you can see. Okay, so you're somewhere off screen up here at the moment. And here we are, right down here in South Africa. And if I zoom in, we'll get a bit better an idea. Okay, so that's Mozambique on the right. We've got Botswana, Zimbabwe, here's South Africa. Nelspruit, you can just see there. That's where I am at the moment. And running all down the side here is the world famous Kruger National Park. So Nelspruit is actually the capital of our province. In terms of degrees for us, we're about 30 degrees east, 25 degrees south. The Tropic of Capricorn actually passes across Kruger National Park. So we are just pretty much subtropical. So we're coming into summer here. We've had a bit of a scorcher. I was saying it was about somewhere between 95 and 97 degrees Fahrenheit today, which was considered relatively cool for this time of year. But it's probably around about 60, probably 70 or 75 at the moment. Right, so that should give you an idea of where we are. So I thought, and Samuel, please feel free to jump in any time, but I thought the next thing we do is actually just sort of give you an idea with Stellarium of what we're looking at from my latitude, if that's all right.
Yeah, it sounds fantastic, man. I'm so excited about the certification program you have. That's something that I've been starting to think about here in Wyoming. So I've got my work cut out for me.
Well, very happy to collaborate. As I said, yours may be a little bit more in depth than mine is, but it's very much aimed towards the guides, and but to be a guide is to be a storyteller. You've got to entertain your guests as well. So as I said, we've tried to focus. Yes, you've got to have a good understanding of the mechanics of it all, but we've tried to stay too much away from the complex astrophysics. Probably, as I wrote it and don't fully understand it myself, that was probably part of the reason. Right, so just to give you an idea, so this is basically what I can see above me at the moment. So you can see looking straight south. So there's Fornax, which you say is right on your horizon. So that's almost at the zenith for me. In fact, it's not showing the zenith at the moment, but that's pretty much directly above me. So there's probably quite a lot of constellations here that a lot of you guys have never seen or heard of. And we do have a lot of very obscure, weird constellations down here. They're not quite as pretty as the ones that we're all used to seeing in terms of the zodiacal constellations. And a lot of these were only documented and catalogued, some of them as late as the mid-1700s. Sort of in this area, it was when the European explorers came down here. There was a big hole, obviously, in the Southern Hemisphere left by the Greeks and the Babylonians and the Sumerians and the Romans. But they didn't have any record for the deep south, as it were, until the European explorers came down. So you'll notice that quite a lot of these have got animal names. So you've got Grus here, which is a crane, Tucana, the toucan, although it's probably actually a hornbill. And then we've got, what else? A chameleon, Apis, the bird of paradise, Pavo, the peacock. So there's about 12 or 15 constellations. So 12 constellations that were named in the late 1500s by a couple of Dutch explorers by the names of Kiezer and de Houtman, with the help of Plancius, who was a Dutch cartographer, who then put these into mainstream, if you could say that. And then we've got quite a few also very obscure, to be honest, and not very easy to find constellations named after sort of the arts and science. So Fornax obviously being a furnace. Sculptor, we'll have a look at the Sculptor galaxy hopefully shortly. That's named after a sculptor's workstation, basically. Probably the most interesting one to mention here, you can just see here, so the two Magellanic Clouds, which we're going to talk about as well, the large and the small Magellanic Cloud here. And you see this little constellation here called Mensa, which is, it's two little tiny stars. It's actually very difficult to pick out, but the LMC acts as a nice guideline for you. But all these ones named after scientific equipment was from a French gentleman or a French astronomer by the name of Nicolas de Lacaille, who did, in less than a year, catalogued over around about 10,000 stars from his observatory at the base of Table Mountain down here in South Africa in the mid-1700s. And he was so blown away by the beauty of Table Mountain, and if anybody's seen it, he actually named a constellation after it. So Mensa is kind of the odd one out. So Mensa being table in Latin, of course. But Octans was his. Other things that de Lacaille was famous for, or probably most famous for, is the Argo Nabis, the big ship from Jason of the Argonauts, which used to be the most massive constellation in the sky. Again, around about that time, he split it up into 4 smaller constellations. So we now have, you can just see it's beginning to rise. Canopus here, the second brightest star in the sky, of course. So it now is Puppis, Vela the sail, Puppis is the stern, and then we've got Carina the keel, and Pyxis is the compass. So he was a very influential astronomer down here in a very, very short period of time. And there is a plaque by the SAAO headquarters, the South African Astronomical Organization down here, that says thank you for the work of recognizing his work down here. But main things that we're going to look at, just to give you an idea of what we're going to look at, I'm going to look at or concentrate on 3 or 4 main things. Obviously, I'd love to be able to show you the Magellanic Clouds, but through a 2,500 millimeter telescope, it's not possible. So I did snap a couple of photos of those for you guys, long exposure pictures over the last couple of nights, because we've actually had some clear skies. Being summer, we do often get some cloud cover, but we've lucked out over the last few days. So the main things we're going to look at are actually sort of associated with these to some extent. So 47 Tucana, we're going to have a look at that and take a couple of photographs of it and try and bring out some detail for you. That's the second brightest globular cluster in the sky behind Omega Centauri, which you guys, I think, are also not able to see, which is a real shame, because that is a showstopper. So we'll have a look at 47 Tucana globular cluster right next to the small Magellanic Cloud, but not associated with it in any way, shape or form. They are massive distances apart. So unfortunately, I'm not really going to be able to show you anything other than a picture of that. Then we're going to move up to Sculptor, if I can find it. Where's he gone? Oh, I'm spinning around. So up to Sculptor, where we're going to look at the Sculptor galaxy, also known as the silver dollar. Oh, wrong one. So the silver dollar galaxy, or the silver coin galaxy, because it's quite flattened. We're looking at it rather side on. A very interesting elliptical galaxy with lots of star formation happening in there. I think I'm right in saying it's the 5th brightest galaxy in terms of magnitude in the sky. You can pick it out with binoculars on a clear night down here. And then I'm going to finish off with what's probably one of my most favorite objects to look at in general, also just because of the principle of what it is. Which is right here, the Tarantula Nebula, which is one of the most massive areas of star formation within the local group, and is a part of that large Magellanic Cloud. So I think we'll finish with that one, depending on how we're going with time. We might try for the Great Barred Spiral Galaxy in Fornax, although it will depend on the conditions. Because we've had a hot day, there is a little bit of atmospheric disturbance, and that one is quite faint. Otherwise, if people are keen, I mean, the Orion Nebula, if you want to see what it looks like upside down, we can do that for you. And I've got Mars, Jupiter, and Saturn nice and, where are they now? Oh, well, actually, no, Jupiter and Saturn were a bit late. Sorry, it's a bit later than I'm normally out, but Mars is in a nice place if you want to have a look at that one too. I think before we get cracking in terms of sort of specific detail on things, does anybody have any questions, or Sam, do you want to add anything?
That was a fantastic introduction, Ben. I really appreciate it. I don't have anything to add right now. I'll definitely chime in and share some facts about the different objects when we see them. Somebody just mentioned in the chat that they're not seeing your screen. I'm seeing your screen. I wonder if other people are as well. Maybe a couple folks can mention in the chat whether they're able to see your screen. It looks just fine from my end. Somebody else said they can see it. Yep, they're seeing it.
Yeah.
I think we're good. One
If
person.
it's a problem, I can stop and reshare if needs be.
No, I think we're good. It sounds like someone just might have their Zoom screen minimized or something, but everyone else can see it, so I think we're good. But thanks for everyone who chimed in there to check that for us. So yeah, let's go to the first object then, and then we can chat more about the details of it.
All right, fantastic. While I'm here, I just want to point out a couple of other things that always sounds like I'm showing off that we can see down here that are fantastic to look at that you guys unfortunately can't. We've got the Southern Pleiades, which is considered one of the big five of the African night sky, and of course we've got the Essa Carina Nebula as well. Which I don't. Can you guys see that at all from where you are, Sam?
No.
Not at all. Because that's also, again, I've got too much zoom for that. It's sort of taking parts of it. But again, that's an incredible piece of sky just to look at.
Yeah.
Right. Let me see. You guys are seeing my screen.
Hi.
So. Right. So the small Magellanic Cloud, I thought we'll start with. So of the two Magellanic Clouds, which of course are named after Ferdinand Magellan, who was a Portuguese explorer who came down here in the 1500s. So they were originally, well, that name was actually sort of given to them a little bit later on. We also know them as the Cape Clouds down here as well. Looking around about sort of around 1519, 1522, Magellan did his first circumnavigation of the globe, and that's where the sort of first reports came from. But obviously, in cultures in Australia, the Aborigines and so on and so forth, obviously there are records dating back an awful lot further than that. But if no one has seen them before, they do look like patches of cloud in a dark sky. It's like the weather refused to clear and continues to refuses to clear in that area. But a quick scan of binoculars will start to pick out all these individual stars. And in this image that hopefully you guys can see on the screen at the moment, you can see the main part of the small Magellanic Cloud, which was, we think, probably a spiral galaxy at one point in its life, and you can still see a sort of a central bar going across it. Obviously, I wasn't able to bring out as much detail as we perhaps would like to see its full structure. And there is 47 Chicano as well, which we're going to have a look at in a little bit later. But as I said, they are completely disassociated from each other. 47 Chicano is around about 16,000 light years away, whereas the small Magellanic Cloud is somewhere between 180 to 200,000 light years away. So the SMC and the LMC, its big brother there. Again, Sam, I'd be interested to hear your opinion on this, but because I think it's still changing. I just realized I picked up another little globular cluster here.
Yeah.
These for a while was considered to be just orbiting the Milky Way, but I think from what I understand of it now, just by looking at their orbital velocities, something doesn't make sense if they were orbiting us, unless our calculations of the mass of the Milky Way is very, very wrong. They're going too fast, and therefore it's now assumed they are sort of bypassing us on the way past. But the gravitational interactions between the three galaxies, ours, the much larger of the three, obviously, plus these two have sort of pulled them all in different directions, and that's why they're now basically referred to as irregular galaxies.
Yeah, and I think the jury is still out about that. They're definitely interacting galaxies with the Milky Way. And as you said, for a long time, they were always described as satellite galaxies to the Milky Way, smaller galaxies orbiting around the Milky Way, just like the moon orbits around the Earth. But new data has suggested that there might be more to the story than that. They might just be passing by based on their velocities. And hopefully with the new telescopes that are going to be coming online in the next several years, the James Webb Space Telescope, the 30-meter telescope, we'll get the data we need to say one way or the other.
Yeah, let's hope they get it launched, eh?
Yeah.
But just as sort of some vital statistics for you, in terms of sort of size, we're looking at about 7,000 light years in diameter, which obviously proves it's an awful lot smaller than us at least 120,000 for the Milky Way. Obviously, a lot of conjecture as to how many stars are in there, but certainly a few hundred million, so a lot less than ours. I think probably for me the most interesting feature about it, other than the fact that it's obviously a pretty amazing, and it still blows my mind, and people get, kind of have to persuade people that they are looking at a galaxy when they see this big cloud, because we've been so sort of indoctrinated by these Hubble images that they see a cloud in the sky and don't realize that it's actually quite as close as it is in the scheme of things. Is the research, of course, that was done by Henrietta Leavitt and the Sifford variables, which we use to measure its distance, with the period of the flashing versus the size of the star, and then being able to compare absolute and apparent magnitudes to figure out distance. I talk quite a lot about that in the manual that are written. Those sorts of things are mentioned. It might be a little bit too in depth, but sorry to revert back to the manual, but obviously that's where I keep going to and have come from. But what I've tried to avoid there is people ask questions, why or how do you know that? And the idea was to try and put as much explanation in there so that all that information was there in front of you. But as you said, they are, the LMC and the SMC are interacting with each other and with us. And again, some of you may know that even though there's about 75,000 light years between the two galaxies, there is a string of stars, or a stream of stars connecting the two, suggesting that they are stealing matter off one another. And certainly you can see from the Large Magellanic Cloud, that area of star formation that we're going to talk about, the Tarantula Nebula, is probably there because of all these crazy interactions that have been happening. So let me show you a picture of the Large Magellanic Cloud.
Ben, one question a couple people asked, that yellow star that we could see in that last image, do you know the name of it?
It is one of the stars in the constellation of Hydrus. I would have to double check exactly the name of it, but that's easy enough to do. Oh no, sorry, it's not Hydrus. I was the wrong way around. Yes, I think it is. Yeah, it's this one. It's Beta Hydrus, basically.
Very cool. So the second brightest star in the Hydra constellation.
I believe so. Yes.
Nice.
I think if that's right, I'd have to check the orientation of my picture. Hold on. And I've now got rid of it. Can I come back to that?
yeah, that sounds okay. No, I think that was helpful.
All right, so here is the Large Magellanic Cloud. Again, so this was taken with just a 70mm camera lens, just on a regular star tracker, a star adventurer. This is about a 90-second exposure, but where I am at the moment from here, and it's still relatively low on the horizon for us. It doesn't still get much above about sort of 30-40 degrees. So there is still some light pollution here. So I've had to deal with a bit of that. But hopefully you can clearly see this central barred structure and what was once a spiral galaxy before it's been ripped apart by all these gravitational forces. And all of that gravity, of course, has caused things to bump into each other and cause plenty of gas and for new stars to be created. And this little bright patch down here is the Tarantula Nebula that we'll finish off with and have a chat about that. I think I'm right in saying it's the third closest galaxy to Earth, depending on what you consider a galaxy, because you've got the Sagittarius Dwarf Galaxy, and then there's this Canis Major, I think, what do they call it? The Canis Major, I even wrote it down, overdensity. That's what I think is the official name for it, because it's a sort of I don't know too much about that one, but I'm assuming it's sort of on the cusp of being a dwarf galaxy or not.
Yeah, I don't think anybody knows much more than that.
Fair enough. Okay, again, just I don't want to sit here and just quote vital statistics at you, but in terms of size, just to give you perspective, if the small Magellanic Cloud's about 7,000 light years across, this is about double that, about 14,000. Contains, what do we say here, about 60 globular clusters that have been found in there, 400 planetary nebulas, plenty of open clusters, a lot of which are relatively young, so brought about by all these gravitational interactions. And then one which I wish I was more into astronomy when I was, 9 years of age, which is the supernova that was seen there. And I think I'm right in saying it was the first supernova to have actually been witnessed with a telescope. That we're aware of, which is S1987A, which I was trying to figure out exactly where it is, but it was somewhere in this region close to the Tarantula Nebula, and at its peak it got to a magnitude of 3, which is not bad considering how far away it was. Obviously it's dissipated since then. Yes, well, still hoping one day I get to see one of those in the flesh, as it were.
Me too. You know, whenever I'm talking to people about supernovae, and I point out Betelgeuse and Antares, which are our two red supergiant stars that are likely to explode sometime between tomorrow and the next million years, I'm always hoping while I say that, one of them explodes behind me.
Yeah. Well, I can add Etta Carina into the mix as well, of course.
Yeah.
Which again, you know, people thought it was going to go. I forget what year it was now, but it became something like the second brightest star in the sky, and now you can barely see it with the naked eye. It's been pulsating so crazily over the last X number of years.
Yeah. Somebody just asked about how many galaxies there are in the universe. I think the current estimate is 1 trillion. 1 trillion galaxies.
I mean, I've heard stories up to 500. No, I think you're right. Yeah, 500 billion, 1 trillion, a lot. I mean, the Hubble Ultra Deep Field, when I do my talks and things, I pretty much always finish with that because it's so impressive. I mean, 10,000 galaxies in an area, the equivalent of holding a tennis ball up from 100 meters away.
Yeah.
If you do the maths, I mean, it's scary.
Yeah.
It's humbling, perhaps, is a better word. Any other questions or anything you want to add about the Large Magellanic Cloud, Sam, or anybody else before I go to another? Well, before we go to a live image, hopefully.
Yeah. Nothing for me. Anybody else? You're welcome to either type a question into the chat or unmute yourself and ask it if you'd like. That's totally fine.
I will take that as a not at the moment. We can always come back to that.
One question just popped up. How many years in a light year? Great question. It's a confusing term. Even though it sounds like time, it's actually distance that we're measuring in a light year. And it's the equivalent of about 6 trillion miles. And Ben, maybe you can add what that is in kilometers.
It's about 9.5 trillion kilometers. Yes, we normally just round it up to 10, otherwise known as a very long way.
Yeah, indeed. Yeah.
So
traveling
the large.
Oh, go ahead.
I was just to say, so the Large Magellanic Cloud is about 160,000 light years away. So a nice way to think of it is that this picture that I took, the photons of light that hit the camera lens the other night to take this picture, left this area of sky 160,000 years ago, have been winging their way through space for that long until they smashed up against the center of the camera. So yes, this is a picture of what it looked like 160,000 years ago, not what it looks like now.
Great explanation. Another question about what happens in a black hole. Maybe we'll save that one for a little bit later.
Yeah, please.
But yeah, Ben, why don't you start going for that first image, and I'll tackle a couple of the questions that are coming through in the chat. Great questions, everybody. How many stars are there? So about 1 trillion galaxies, that's the estimate right now. And on average, we think there are about 200 billion stars in each galaxy, give or take, several tens of billions. But in astronomy, if you're within an order of magnitude, you're doing pretty well. So 1 trillion galaxies, 200 billion stars in each galaxy. If you do the math, you end up with the number 2 and 23 zeros after it. So that's the estimated number of stars in the universe. 2 with 23 zeros after it. So a lot, a lot of stars.
Hi, Sam. This is Mike Adler. Another way to say that is that that's within a couple of orders of magnitude of the number of grains of sand on the Earth.
Yes, I love that analogy. Thanks, Mike.
Yeah, sure.
Yeah, so just as many grains of sand as there are in the Earth, that's how many stars exist in the universe. And Dave Koster just shared a link. 2 trillion galaxies in the universe now. Interesting. Yeah, that number keeps going up and up as our technology keeps getting better and better. I've got a feeling it's going to keep on rising.
Sorry, Sam, just to jump in, I just realized I need to grab something from inside. So I'm just going to disappear for 30 seconds.
All right, sounds good. So that question about what happens inside a black hole, unfortunately, that's not a question that that I can answer or that anybody else can answer. It's a big mystery because we can't see inside a black hole. One of the characteristics of a black hole is that no light can get out past its theoretical edge called the event horizon once it passes that point. And so what goes on inside a black hole is a complete mystery to us, and it may be something that we never are able to answer. We do think that there's a central point in a black hole, which we call a singularity. And so all the stuff that passes the event horizon and eventually makes its way to the singularity in the center of the black hole, but we don't get to see that. In fact, as we watch things approach black holes, what we see is them getting closer and closer to the event horizon, but their speed getting slower and slower as they approach it. And it appears as though time stops for them as they approach the event horizon. So we can never actually even see anything fall into a black hole from our perspective on Earth. And so they really are truly bizarre objects. But as a lot of you guys might know, we actually got a picture of what all of the really, really hot gas and dust looks like around the outer edge of the event horizon just last year for the very first time. So now we actually have a picture of what the outside of a black hole looks like. But no pictures of inside a black hole, and that may be the case forever.
But, I might add, Samuel, people have, even though we can't see inside it, the physics around the event horizon aren't that complicated, and people have analyzed what would it be like to actually, if you were a person or being sucked into the black hole, what it would feel like. So that has been studied. As you say, though, when you get to the actual singularity, that's where we don't have physics anymore. We don't have the proper physics to understand that. But before you get to you will get stretched big time.
Right.
But it's interesting. The bigger the black hole, the smaller the amount of stretching will occur at the event horizon. But the small black hole, you're going to get stretched real fast.
Yeah, I think Stephen Hawking coined the term spaghettification to talk about that stretching that happens.
Yeah.
So yeah, you get spaghettified if you fall into a small black hole. You're back with us, Ben?
I'm back and ready when you are. Always nice to learn more about black holes. Okay, right. So whilst you guys were away, you might have seen it on the screen because I forgot to stop the sharing. So what I've got is just using a program called Digicam Control, and got my telescope all set up previously. I'm having a little issue in terms of focus, but I think there are some just very faint cirrus clouds high up. As I said, we have had a hot day today, so it wouldn't surprise me. But here it is. This is 47 Chicano, the second brightest globular cluster in the sky. And if anybody's not sure what a globular cluster is, it is a gravitationally bound group of hundreds of thousands of stars way out there in the halo of the galaxy on the outskirts. So this is it's definitely the second brightest. Sam, maybe you can help me here whether it is the second largest in terms of mass. That I'm not sure about. I'm
actually not sure about that either, but definitely one of the largest.
And in terms of sort of order of magnitude there, so we've got Omega Centauri, which is spectacular to look at. It which sort of reminds me of a swarm of bees. It's like this, but much bigger and more intensive. I'd love to show you that. That's just coming up above the horizon now. So maybe if we do this another time of year, we'll certainly do it because that's always worth having a look at. That's the brightest one in the sky. They're followed by this one, and then I think the third brightest one is what's called the Pavo globular cluster, and in Pavo the Peacock, another one of those constellations we mentioned earlier. And then fourth down the list is I think the brightest one that you guys can see, which of course is M13, the Hercules cluster. So we're very fortunate down here to be able to, we've got a lot of views of some of the most stunning globulars in the sky. And estimations suggest that what you're looking at there, what I've actually done for you actually is I've quickly exported into Photoshop, and I'm just going to do a quick sort of curve stretch on it and see if we can get rid of some of the light pollution there, and that sort of halo that you can see the ring is from the focal reducer. So I'm just going to see if I can try and get rid of some of that. But it still blows my mind that in one little field of view, we were looking at potentially 500,000 stars all in one place. And if we go if you delve right down deep into the middle of the cluster here, which obviously from this photograph has just come out as bright white, because 47 Chicano is one of the most densely packed, or its core is one of the most densely packed globular clusters in the sky. You're talking about in an area that is perhaps 10 light years across, which isn't much astronomically speaking. If you think our closest star after the sun is 4.3 light years away, I think you're talking thousands, tens of thousands of stars packed within that tiny area, so closely packed together that you couldn't even fit our solar system between them. And there's lots of variable stars, and there's this chaos happening in the middle. And because they're so tightly packed, and it's so bright in there, there's still, even today, a lot of conjecture about what is in the middle. We've been talking about black holes. We think there is probably an intermediate sized black hole in the middle of this globular cluster, and probably other globular clusters for that matter. So you've got stellar black holes, which are the much smaller ones left behind when a supergiant explodes. These ones in the middle, an intermediate one, and then the supermassive black holes that you find in the center of large galaxies, well, I wouldn't say all galaxies. I believe there are one or two that have been found without now. Just to throw a spanner in the works. Yeah, most galaxies, exactly. Yeah, so it's amazing to me that you're actually looking at here in an area the size of basically a full moon, which is pretty much the full moon just fits in the field of view of my camera with the focal reducer on. So that the globular cluster itself stretches out to about that sort of halo of white light that you can see around it. Obviously, I haven't been able to pick up all the faint stars, but hopefully what you can notice is that a lot of those stars are quite reddish in color. We've got a lot of orangey colors there instead of the bright whites and the bright blues that a lot of people might be used to seeing. And that's because globular clusters are incredibly old, nearly as old as the universe itself by some estimations. And I think, well, I know 47 Chicano is catalogued as one of the older ones at just over 13 billion years old, which is not too far off the age of the universe. So these are ancient stars, and it's kind of a stellar graveyard in there as well. You've got neutron stars floating around, you've got lots of stellar mass black holes floating around, there are white dwarfs dotted around, and this is the same for a lot of globular clusters, but there seem to be more than normal in 47 Chicano, as you have a lot of over 20 what are called blue stragglers which have been found, which you wouldn't expect to see. This is an old group of stars, and blue is a hot, bright, vibrant color given off by young stars, giving off lots of X-rays and other very short wavelengths of light. So the question is, where do they come from? Because there shouldn't be any star-forming material left in this globular cluster after 13 billion years. But because it's so tightly packed, and you've got lots of double star systems and triple star systems that are all sort of wheeling around each other, that potentially occasionally they bump into each other, or they slowly merge, and there's some sort of cataclysmic event which allows for new stars to be born. So you've basically got sort of two generations of stars, of grandparents and grandchildren, if you like, in one place, which is a nice way of looking at it. And again, very special for us down here, because this was also discovered by that French astronomer, Nicolas de Lacay, from his observatory here in South Africa, just down there by Cape Town.
Very
cool. If you want to add, I mean, I have lots of other things I could say, but I don't want to drown people in information. I just, regardless of the interesting science behind it, that's still a collection of 500,000 stars that you can see at once, and it's pretty amazing. See if I can get rid of that.
I'll just add one thing. So there have been a couple questions about exo solar planets in the chat. Planets like Earth, or like the gas giant planets in our solar system found around other stars. And we've discovered lots of those already. I think over 4,000 exosolar planets are known now, with about 20 or 30 of those somewhat Earth-like. But interestingly enough, in these globular clusters, we don't see any planets. And that has to do with what Ben was just talking about, that the stars in these planets the stars in these globular clusters are really, really old. And they're made up of the original stuff left over from the beginning of the universe, the Big Bang, the primordial hydrogen and helium. And the heavier elements that are produced in the cores of older stars and then expelled when stars explode just aren't present in these globular clusters. So we don't have all the raw materials necessary to make planets in them.
Sorry, send me back. Yeah, so as you said, Hubble did a big survey looking for planets and found none, which, as you say, is very unusual. But even if maybe there are one or two planets still floating around in there, but with all those stars so close together, all sort of bumping off each other, there's a high chance even if there was a planet that was formed, it will probably be destroyed by all those gravitational forces anyway. But if there was a planet, imagine what the star or the sky would look like from a planet within the center of there. It would be blindingly bright. I actually think somebody once described it as putting like a pasta or spaghetti colander above you and having a spotlight shine through it. That must be what it's like. That was quite a nice analogy. I like that.
I like that. Yeah. The other thing I wanted to mention actually was about the potential intermediate black hole in the center of this globular cluster. There's still some contention about whether it or not it's there. But the interesting thing about it is that we don't really see intermediate sized black holes anywhere in the universe. We see stellar mass black holes that are, on the range of 10 to 100 times the mass of the sun. And then we see the huge supermassive black holes, which are millions or billions of times the size of the sun in the center of big galaxies. But the intermediate sized black holes just don't seem to be anywhere. And so if we actually confirm the existence of an intermediate sized black hole in the center of this globular cluster and Omega Centauri, we'll be on the verge of understanding why we've been missing them so far, and that they in fact indeed exist somewhere.
I'm just going to put a quick picture of Omega Centauri that I took up so you can sort of see what that one looks like as well, the brightest one in the sky. So you can see in terms of just I've got a bit of field rotation in here, as you can see, but just in terms of the amount of space it takes up on the screen, here you're looking at sort of potentially 10 million stars as opposed to 500,000. And again, I don't want to go too off topic. And again, Sam, I'd be interested into your theory on this, because one thing that I've always struggled with, and I think people still do, is where these globular clusters actually came from. Were they formed out of isolated chunks of dust and gas way on the outskirts and have just managed to avoid being pulled in towards the center? Or, as is the case with Omega Centauri being so large, I believe that is considered to be the corpse of a dwarf galaxy that the Milky Way swallowed at some point, because we've got the star streams of stars moving in different directions and different speeds, which suggest a different origin. And again, to just think of these things as potentially the corpse of a galaxy that was cannibalized by our own galaxy is a pretty far-fetched yet potentially true idea. Like something out of I'd say sci-fi movie, but it is exactly that.
Yeah, I mean, we're definitely gravitationally bound to them now, and whether they were much larger independent galaxies before they became gravitationally connected to the Milky Way, we don't really know. But we do know is they tend to hang out in the upper and lower halos of the galaxy, as opposed to in the plane of the galaxy where most of the stars are. And so the fact that they're not in the plane of the galaxy where most stars hang out leads us to believe that they didn't actually form within the Milky Way, but they formed elsewhere and were gravitationally pulled in. But we don't totally know their history yet.
yeah, and it'll be interesting to see whether we steal any more from the Magellanic Clouds on the way past, which is definitely possible.
Yeah.
I'm just trying to see if we can do anything else here. This is such a difficult one to photograph in it with a single exposure. As you can see, you've got such a bright core because of that density, and then not enough brightness around the outside. But so hopefully you guys get an idea of what you can see there, and say through a telescope, even though it's not as bright as this, it really just has come to life. So it's like a flies buzzing or bees buzzing around the honeypot. It's an amazing sight. Okay.
Should we move on
Right,
to the next object?
Yeah, I was going to say, unless anyone's got any questions about that one, I think let's have a look and see what else we can find. Right, let's hope the telescope plays ball.
Yeah.
Right, what do we say?
Go ahead.
Okay, so we're going to go for the Sculptor Galaxy.
Yeah.
So NGC 253, I believe. So this is so as I said, one of the brightest, top 5 brightest galaxies in the sky, and so certainly on a clear night and on new moon, no issues at all in trying to pick it out with a pair of binoculars. You can do the same with the Centaurus A galaxy as well. So the noise you can hear is the telescope slewing to the right target, hopefully.
And while it's doing that, we had a question in the chat about how are stars made? What a great question. Basically, we think that stars form out of huge clouds, bigger than the entire solar system, made up mostly of hydrogen and helium gas. And just because of gravity, those clouds start clumping up and collapsing in on themselves. And eventually, there are clumps that get so hot and so dense that nuclear fusion begins. That in the center of those clouds, light begins to be formed because of these nuclear reactions. And that's the core of a baby star being born out of these gigantic gas clouds. And we're actually going to take a look at one of these gas clouds for the next object. We're going to look at the Tarantula Nebula. And it's one of these huge, huge clouds of gas that's giving birth to baby stars. So we'll hopefully get to see that in just a little bit.
Yeah, I'd actually gone to the Sculptor Galaxy, but let me go to the Tarantula Nebula, and we'll finish, or we'll do the Sculptor Galaxy next. We'll
okay.
It
doesn't matter. The order is not too important.
Yeah. Right, well, let me see if I've got it lined up on Sculptor first.
Yeah, if you got it lined up, we might as well take a picture and take a look. We can come back to the Tarantula later.
All right, currently I can't see anything. Right, I'm just going to go and check what's going on there. Sorry, I'll be back in a second.
Okay. Yeah, so our sun is a star, just like all the other stars we're seeing in all these images. And it formed out of one of these huge gas clouds as well. The cool thing about our sun is that it formed out of the leftover stuff from a previous generation of stars that had already made all the heavy elements in their cores necessary to make planets and everything on planets, including us. And so our sun, because it formed out of the leftover stuff, the debris of a previous generation of stars, it had all the raw materials that it needed to form planets and us. In contrast to the stars that we saw in the globular cluster that we looked at. Those stars formed out of clouds that were just hydrogen and helium. So they didn't have any of the heavier elements like iron, silicon, nickel, copper, etc. To form planets, which is why we don't see planets in those globular clusters. But our sun was different. Our sun formed from recycled star stuff, which is why we're here today. And eventually our sun and all the planets will become a big cloud of gas moving out through the universe, and will probably form another generation of stars. And so there might be a conversation going on like this in several billion years where people will be talking about how they're made up of recycled star stuff, and they'll be made up of the stuff left over from our solar system. How we doing, Ben?
Not good with the Sculptor Galaxy. My telescope seems to be not pointing in the right place. So you may get your wish, and I'm going to go to the Tarantula Nebula instead.
Right.
So I therefore assume you've somehow sabotaged me from the other side of the world. Right, hopefully this one will work. I hope we haven't lost alignment, because that will be a pain.
No,
Right, well, they will,
played that
as you
game before.
suggested, we'll... Oh. Sorry, just some technical difficulties with the cabling. Yeah, so hopefully now we'll go to that Torrential Nebula, as you said, a huge area of dust and gas, and basically a little stellar nursery where lots and lots of babies are. That would be why, because I've just looked up and seen there's a big cloud over my head. I didn't think to check that. You think Occam's razor, the simplest explanation is normally the correct one.
Yeah.
Yes, right. Well, let's hopefully that won't last too long. So I don't want to waste everybody's time. So what I will do is let me just go to a photo of the Sculptor Galaxy, which again was taken on Friday night. So it's relatively up to date. At least you guys can see that. And then I'll also show you a sort of a Hubble or a European Space Agency picture of it as well. So you've got an even better view. Sorry about that, guys. That is the issues here in summer. Right.
That's how it goes. We have problems with clouds here in Wyoming as well.
Right, there you go. So that is NGC 253, otherwise known as the Sculptor Galaxy, or the Silver Dollar, or the Silver Coin Galaxy. So you can see how bright it is just from that picture. And that's why you can pick it up relatively easily with binoculars in dark skies. Now, whereas 47 Chicano that we were looking at was still over 16,000 light years away from us, that was still within our galaxy. And then we did look at the two Magellanic Clouds around about 160, 190,000 light years away. Now we've somewhat upped the ante, and I think this is actually one of the furthest things I've photographed with any sort of detail. I mean, we're looking at about 12 million light years away now. So again, this is what this galaxy looked like 12 million years ago, not what it does now. You can see it's got that sort of standard spiral shape that we've come to know about galaxies, even though we're looking at it fairly edge on. But I think, and it was discovered by, I forget her first, Caroline Herschel, who was the younger sister of William Herschel, of course, who discovered Uranus as well, and a variety of other things. It's nice they kept it in the family. But what makes this one particularly interesting is you can see how bright the center of the galaxy is, and actually, if you obviously we've been able to examine these stars in a lot more detail. That we actually got a lot of young stars in the center of the galaxy, which is unusual because normally the central bulge of the galaxy is made up by old reddish stars, and then the younger, hotter stars are within those spiral arms. But here it's almost the other way around, and we've got a lot of star formation happening in the middle of the galaxy, which categorizes it as a starburst galaxy because it's having a big explosion of star formation. What triggered that? Again, a lot of conjecture, but it's suggested that just like we were talking about the Magellanic Clouds, and just like the Andromeda Galaxy is rocketing towards us at, 500 kilometers a second or whatever it is, and the two of us are probably going to merge in a few billion years' time. We think that this galaxy underwent a merger with another galaxy about 200 million years ago, which is not long ago at all in astronomical terms. And again, that sort of gravitational disturbance has agitated all those clouds of dust you were talking about, made everything collapse on themselves, heat up, nuclear fusion, bam, lots and lots of baby stars being born. And somewhere in the middle there as well, we found three what are considered superclusters, which is a great name in itself, I think, and a lot of Wolf-Rayet stars, which I mean, again, they're very difficult. As far as I know, actually, you can't even really see them with amateur equipment because they're so hot and so massive. They give off most of their light in X-rays and gamma rays, which of course is far, far away from the visual spectrum. But they're some of the largest and brightest stars known. In the large Magellanic Cloud that we were looking at earlier, there's R136, which I forget the facts and figures of it, but it's second or third largest star that we're aware of, I think. But these superclusters have got sort of 50,000 times the weight of our sun in them. And again, I think potentially I even asked the question, where do globular clusters come from? And one of the theories is that in these areas of galaxies with massive amounts of star formation happening, that so many big bright stars are born together at the same time that they stay gravitationally bound, and I assume therefore migrate further away from that galactic core. So that's another potential origin of those globular clusters.
Yeah, thanks.
And I think yeah, no, sorry, go ahead. Yeah.
I was going to say a couple interesting connections with this galaxy visible in the Southern Hemisphere with a galaxy that we can see in the Northern Hemisphere, as well as one of the restaurants we have here in Jackson called the Silver Dollar Bar and Grill. So this is the Silver Dollar galaxy here that we're looking at. But we have a couple of interacting galaxies that we can see in the Northern Hemisphere, roughly the same distance away, just coincidentally, about 12.5 million light years. And that's the Cigar Galaxy and Bode's Galaxy. And the Cigar Galaxy looks very similar to this one, actually, when you photograph it. And it's a starburst galaxy as well. And as you were mentioning, some kind of interaction set off the star forming activity in this galaxy in Sculptor, and the same thing happened with the Cigar Galaxy. It interacted with Bode's Galaxy, and that set off a lot of a star formation. So we call that one a starburst galaxy as well.
Okay, I just want to make sure you can still hear me, Samuel. So I had to change devices a little bit. Could you guys still hear me okay?
Yeah, no problem. Sounds coming through perfectly clear.
Fantastic. Yeah, I mean, to be honest, in terms of sort of specific information, extra information to give you about this galaxy, I think I don't know of a great deal else. But again, it's always nice to see, even through the telescope without the aid of the camera, you can still clearly see the shape. And well, you can't quite see these dust lanes that, which I've managed to bring out here. But again, just as I was saying about the globular clusters, to be able to view something that far away, and as you were saying before, I mean, potentially, I'm not sure, I couldn't find out how many stars are considered to be in this galaxy. But again, if we just work on the average of 100 or 200 billion stars per galaxy and all these potential planets and moons, I mean, it just really does get the mind wandering as to what else might be out there. It's quite a sight. But again, I struggle to get it all in the field of view of this telescope. Even with the focal reducer, you can see it's, I'm sure if I had a much longer exposure, we'd get a lot more of the glow around it. In fact, whilst I say that, let me put up a proper photo of it.
Yeah, sounds great.
I think I got all of these from the European Space Agency.
Oh, nice. And so we think this galaxy is just slightly smaller than the Milky Way at about 90,000 light years from end to end. Milky Way is about 100,000. So you can imagine our galaxy just being a little bit larger than this one.
Okay, so there's a picture now you can see in a bit more detail. So again, whilst I have no idea what equipment they would have used there, but I'm still very chuffed that this equipment which I've got, which is really set up for visual work with what I do out here, is still able to capture what you can capture. There's not a huge amount of difference, well, to the untrained eye at least. So I'm still very proud of that one. But yeah, I just love the way you can see all those dust lanes, of course, which we can equate to by just looking up on a clear night with the Milky Way, and you can see all those dust lanes going through. And so I'm going off on a bit of a tangent, but just because we're in the Southern Hemisphere here, and I mentioned those dust lanes, we've got the coal sack down here, which again we can't see at the moment, which is an absorption nebula or a dark nebula close to Crookes, the Southern Cross. And there are references in Aboriginal culture and also Bushman culture, where rather than drawing pictures in the stars to make constellations, they actually use the dust lanes to draw things. And they have the celestial emu or the celestial ostrich, of which the coal sack is its head, and then the neck stretches right the way down. And you're talking about nearly half the sky made up by this giant bird. But when someone points it out to you, you definitely see a massive celestial ostrich or emu when you look up. It's strange, but it's just nice to see that Other cultures also use the dust lanes to tell their stories and to record their memories, as well as just the stars themselves.
Nice. Yeah, I remember seeing the coal sack years ago. I think just about a decade ago when I was in Australia. It was pretty cool.
I think since we mentioned it, I think I've got a it's on one of the pictures somewhere. Where's my one with the laser? So just so everybody else knows what we're talking about, there is the Southern Cross.
It is. Yeah.
See it there. And that is the coal sack, and you can see it's got this little point, which is the beak of the ostrich / emu, and the head, and then right the way down through Alpha and Beta Centauri. There goes the neck, and then it starts to bulge out as you get to the sort of the core of the Milky Way for the body. So it's a huge. You can't really call it an asterism. I don't know what you would call it. A huge dust lane construction.
I like it. And you guys don't have just one star at your south celestial pole, like we have the North Star, but you guys do have the Southern Cross that you just mentioned.
Yes, exactly. It's a very good point, actually. And it's, well, to be honest, it's the bane of my life, trying to line up my little star tracker to take pictures. I wish we had a South Star, because it would take me about a tenth of the amount of time. So the South Celestial Pole, and to find due south as well, we use the Southern Cross in conjunction with these two stars, which we know as the pointers. So there is Crux, the Southern Cross, the smallest in terms of size of all 88 constellations. And you can see it's sort of pointing down here to behind the tree in this general direction. And then we have to take the midpoint of these two stars of Alpha Centauri, our closest star, on the bottom, Beta Centauri on the top, draw a perpendicular line, and where that line crosses that line, so somewhere around about here, is the South Celestial Pole. And then you've got to get a pair of binoculars out to try and find the right shape for around sigma octans if you want to line everything up perfectly. When I took that Magellanic Cloud picture, I tried to do that. It took me, after 45 minutes, I decided that was close enough because it's very difficult to get it spot on. But I got 90 seconds, but I was just beginning to get a bit of worming there. So that's another one of those nebulas, say a dark nebula or an absorption nebula. Looks like a black spot in the sky, but even through binoculars, or if you scan that area in a low magnitude telescope, you will see lots of reddish colored stars there. Not necessarily red because of the color, but just because only the longer wavelengths of light can actually get through this cloud of dust and gas. And all of these dark lanes are clouds of dust and gas between us and the line of the Milky Way, those spiral arms.
Nice.
Okay, let me just have a look and see what's happening up above me.
Yeah, I'm just going to ask.
Yeah.
Honestly,
Samuel, I have an image of another galaxy in the Sculptor constellation that I just finished. Can I share, or is it?
You might be able to, Mike. Give it a shot.
All right.
Ben, how's the sky looking while Mike's getting that up?
Is that NGC 300?
Okay.
I wanted to have a look at that one.
NGC 7793.
This is 7793.
Yeah. Okay.
Yeah, I just finished it. I don't have a telescope but I have access to a telescope in Chile, and so this picture was just taken, and I just completed processing it. So anyway.
Very cool. Thanks, Mike.
But it is a beautiful. It's called a flocculent galaxy because the spiral arms are not continuous, and there's a complicated theory as to what makes a flocculent versus a spiral. But anyway, I won't go into that. But it's a beautiful object, I think, though.
It is indeed.
Yeah. Yeah, stunning.
All right, I'll pull out of this then and stop sharing.
I'm going to try. There might be a bit of a gap in the cloud where we're looking, so let me try. And if it doesn't work, it seems to be there's just sporadic gaps. Sorry, guys, it's just the way it goes sometimes. But let me see what I can do.
73.
And so for those of you who don't know, Mike, who just chimed in there, Mike is one of the board members of Wyoming Stargazing, and he has an amazing observatory here in Jackson, and he helps us out with the virtual stargazing programs that we do from Wyoming.
Right, so I'm just taking a 30-second exposure, still at ISO 4000. If it doesn't work, well, hopefully we'll be able to see something. If it doesn't work, I'll show you the pictures of the Tarantula Nebula that I took again a couple of nights ago. This is why I now feel glad that I did some prep work for this, for this eventuality. Okay,
if we could control the weather, we'd have other jobs.
Very true, and no one would trust us either. Okay, well, we've got a bit of something there. There is definitely some cloud, but let me share this with you, and then at least you can see what we're looking at, and then I'll show you the better pictures afterwards. Right. Okay, share screen, share. Okay, hopefully you guys can see that. Let me zoom in a little bit, and yeah, so there's definitely some cloud obscuring the image, but I'll show you the proper image now, but you can just see that sort of bright central core. So this is the Tarantula Nebula that we are looking at now, that area of star formation within the Large Magellanic Clouds. So there's that very, very bright core, also with some superclusters and things going on in there. And you can just begin to see some of these sort of tendrils, if you like, of dust and gas here, which you'll see more clearly in a moment, which is where the name Tarantula Nebula comes from, because it looks like it's got multiple legs. But in terms of what you're actually looking at here, in all of the local group of galaxies, all the galaxies close to us, this is the most active region of star formation that we're aware of in the local vicinity, because of those interactions we spoke about earlier with our Milky Way pulling at that galaxy, and the interactions with the small Magellanic Cloud. Again, it's the perfect conditions for this. Somehow stellar nursery doesn't sound like a big enough explanation for it. The sort of stellar, I don't know, but you get what I'm saying.
Yeah, stellar. I don't have a good name for it either.
But in terms of what's going on here, again, I never know what to trust in terms of figures, but they're talking about in the region of somewhere between 800,000 and 1 million new stars being created in this small area of sky at the moment, sort of as we speak. And just to give you an idea, even though it's 160,000 light years away, and it is an area of nebulosity, which again, the only area of nebulosity that I think you guys can probably see with the naked eye is M42 and Orion. We can. Can you see the Lagoon Nebula M8? Can you see with the naked eye? Yeah. All right. But this, I mean, you can pick it out clearly. It's an obvious fuzzy blob. It looks like a globular cluster actually from distance until you get up close to it. Let me just try and take another photo, and in the meantime, I'm gonna go and show you the ones that I took the other night.
So I did a little research on this object because I didn't know much about it, and so as Ben was saying, it is an incredibly bright object, and it's really, really far away. So about 160,000 light years, 100 times farther away, or excuse me, 1,000 times farther away than the Orion Nebula. So if this object were at the same distance to Earth as the Orion Nebula at about 1,600 light years, this object would be bright enough to cast shadows, and it would take up half the sky. It would be truly incredible if it were as close as the Orion Nebula.
Yeah, again, what an amazing sight that would be.
Right?
Okay, so here is the same picture that you've just been looked at with a bit of post-processing magic done to it. So you can clearly see now this is exactly the same settings, 30 seconds at ISO 4000. And now hopefully you can clearly see these sort of, I think tendrils is the best name for them, or the legs, which give the impression of this sort of giant spider sitting up there in the sky. I think it's just a beautiful object to look at in itself as well. Also discovered or catalogued by the French astronomer de la Caille from the observatory at the base of Cape Town there. And say home to that supernova that we were discussing. I'd say I can't remember exactly where it is, but it was somewhere close to here. And of course, there are lots of other globular clusters and nebulosity associated with this because of all of that stuff going on. Yeah, I'm trying to think what else. Oh, and actually, we've got Mike, you obviously incredibly talented when it comes to photography. Sam and I were having this discussion earlier, but because this is obviously categorized as an emission nebula, which for anybody who doesn't know means that these clouds of dust and gas are being excited by the young stars, which are being born in there and which are growing in there, and they're giving off lots of energy, and that reacts with this gas and makes hydrogen burn pink, which is, as Sam has pointed out, is what basically stars are made of. And normally just the reflection nebulas glow blue, but whenever I take pictures of this, I always get this overwhelming blue color, whereas it should be pink by definition. So we were having a debate earlier as to whether it is my camera equipment or if there was something strange going on. I don't know, Mike, if you can add anything there.
Well, I actually have a picture of it in true color. That again was taken in Chile, or I got the data from Chile anyway. I can show you that. And this, let's see. There it is. Yeah. Here it is.
And so I couldn't come up with a good reason, Mike, why Ben's images would come out blue other than just some like color balance issue with the camera.
It's strange because like M42 and the Lagoon Nebula, when I take photos of those, they come out as pink, as one would expect. But for some reason, this one has always come out blue.
Yeah, well, this is the Torrential Nebula. This is, I shouldn't say this is true color. This is narrowband. So in this case, red actually is hydrogen, though it's narrowband with hydrogen red, and the bluish color is taken with is oxygen. But I also have a version of this. Okay.
I pulled up one of your true color versions of that, I think, earlier.
Yeah, here I think I have it right here too.
This is all well and good, but now I have to suffer the indignity of putting my picture back off after that.
There's a true color version. Let's see if I can do this. Yeah. Okay. So that's a true color version of the Tarantula Nebula. It was taken in Chile. I don't know if you know a fellow named Martin Pugh. It's his observatory there that I have access to. He's quite a famous astrophotographer. And
I've heard the name.
Yeah. Anyway, so this is my picture of it that came from his telescope.
Cool. Stunning. I think we'll just leave that one up there. That's beautiful. I think the more and looking at these things in different wavelengths of light really sort of brings them to life as well. It's sort of they've got all these different characters, but it's to see the detail in the dust lanes and things there is pretty spectacular.
You probably know a lot more. Yeah, what is amazing also is that in a lot of these galaxies, of course, when we look at them, the stars we see are the stars that are in our galaxy in front. But here, even at this distance, you can actually see stars in this nebula that belong to this nebula. So, which is pretty amazing. Yeah.
That little that group of stars in the center there, I'm assuming that's R136, which is one of these.
This cluster right here. Yeah.
And we were saying about those Wolf-Rayet stars. I think that there aren't many known. I think in our galaxy, as far as I know of, but this one's got like 72 or something of those Wolf-Rayet stars just in that one cluster alone, because of the chaos that obviously ensued in there. So. Yeah, and estimates have it at less than 2 million years old, which I know still sounds pretty old, but when we were talking about those other globulars at 13 billion years old, and this is all relatively recent happenings. So it's happening, I wouldn't say in front of our eyes, it's happening 160,000 years ago in front of our eyes, but yeah.
One thing I don't know, what is this one over here? Is this associated with, is this in the same cloud, this cluster?
I think is that not is it NGC? There is another cluster close by. I'd be guessing, but there is another cluster, whether it's associated with that or not. But if you see a wider field view of the Tarantula Nebula, there's all sorts of clusters and areas of nebulosity within the peripheries of it. So I'm sure it is if we find a detailed map of it.
Yeah.
And I don't think we already mentioned a specific size for this object. We talked about it being the biggest Emission Nebula, biggest stellar nursery, but
Sorry, that's
That's all right. It's over 1,000 light years across. So I mean, it's really kind of rivaling the size of a small galaxy. It's enormous, of a dwarf galaxy.
Yeah. Wow.
there is a little gap in the clouds. I think out of Xena. Shh. Sorry, that's Xena. She's saying hi to everybody.
Yeah, my dog is asleep behind me.
Probably, possibly not after that. Right.
He's
Let me
still
see. Just, I think we're also sort of in terms of time. I think we are getting pretty much there. But out of principle, I think we'll just try and take one picture because there does seem to be a gap in the clouds at the moment.
Yeah, that sounds great, and we can wrap it up. We get a good one.
I also may have lost a bit of focus because it's I focused it a couple of hours ago. But let's see. Just while that's ticking over, can you guys see that? Yes. I had again. I feel out of principle I'm going to put it up because I did it for today, but it doesn't really to follow Mike's image there. But this is my sort of slightly more close up image of it in terms of the detail, which again with my visual equipment, I'm very, very chuffed with it.
What camera are you using here?
I'm using an unmodified 12-year-old Nikon D7000 DSLR.
Well, of course, that is one of the issues. If being unmodified, the hydrogen wavelength is strongly attenuated in a regular camera, as you probably know. Yeah. So that's probably one of the issues here, is that you're attenuating that particular wavelength.
Well, I was very lucky. Nikon actually sponsored me a Z6 mirrorless camera about a month ago. But again, Murphy's Law, it was cloudy most of the time I had it. I think I just managed to get a picture of the Helix Nebula, which, Samuel, I did send you through. But I would have loved to have seen the difference between what I can get with this camera versus the mirrorless one and just the ISO capabilities. I think I took the Helix at 10,000 ISO. This camera doesn't go up to 10,000 ISO, and if it did, it would probably fall apart. So it would be fascinating to see the difference between the two. Let me see
my picture was taken with an astronomical camera that has good, so it receives the hydrogen wavelength very well.
Well, I've got a ZWO ASI 290 that I use for planetary imaging. But it's not good for DSOs, unfortunately. It's the chip is too small. Mm-hmm. Yeah, see, there's still a little bit of I've lost a little bit of focus there. So that's the 30-second image I've just taken now. But hopefully it gives you guys an idea of what you can see. And through the telescope itself, obviously you don't get the color, so this is almost more of a better representation of what you would see visually. But again, I find that often when we're doing a lot of these outreach ones, to try and sort of persuade people what they're looking at can be a bit difficult because it's not much to see. But this is one of my favorites because there is a shape to it and it kind of lives up to its name to some extent as well. So it's I don't know, I find it kind of hypnotic. I think these knots of dust and gas. It's beautiful.
Yeah, the Orion Nebula is similar. You really get to see some texture in the gas, which is pretty cool.
Yeah. Again, one day, this is the best that we've done for Orion. There, so that's the best I've got for Orion, but I need to have another crack at it. That was last year.
No, that's lovely.
Yeah, but again, there's the pinks are definitely there, and I've got a little bit of detail in there. But obviously, I'd like to think I've improved since last year, so I'm very, very keen to get out there and try that one again.
Nice.
But to be honest, Sam, I think in terms of what we're going to look at, especially with the weather, there's another bank of cloud moving in. I think if there's anything else you want to add, then go for it. But I think that's about all I can really share with you guys this afternoon. But I hope it's been enjoyable and a slightly unusual time for you guys to do some stargazing. But I hope it's been good.
Yeah, it's been fantastic, man. The only other thing I wanted to say was thank you. Really appreciate you connecting with us, and I really hope we can do this again. This was a ton of fun.
Definitely, yeah. We'll wait a couple of months, and then we can try and do something with Eta Carina. We've got the Southern Pleiades. We can look at Omega Centauri, Centaurus A. It just keeps coming. It's a 365-day cycle of beauty.
Oh, that sounds great. Well, I'm looking forward to that. And yeah, again, everybody, thanks so much for joining us. And Ben, thank you again. And
Great pleasure.
yeah, and until next time, clear skies.
Indeed. Thank you very much, everybody. Have a great afternoon.
Thank you. Bye.
Thanks,
Thank
everybody.
you.
Take care.